Hi everyone. This lesson is a right triangle application lesson with calculators. So let's get started. When it says to solve the triangle, what you're looking for is to find all the lengths of the sides as well as finding all the measures of the angles. So for the first problem right here, we want to find angle B. We already know that this angle here in the middle is a 90-degree angle that's represented by the perpendicular square there. So we want to find the measure of angle B. So in order to do that, we know that the sum of the angles in a right triangle or any triangle are 180 degrees. But specifically, we know that these two angles here are complementary, which means that they add up to be 90 degrees. So 90 degrees minus 40 degrees is going to give me 50 degrees. And so we know that the measure of angle B is equal to 50 degrees. So, sorry about that. From there, let's see, I'm going to erase this. And so now we know that that's 50 degrees. I'm going to put a 50 right here. And then now we just have to find the lengths of the sides. So I'm going to find side length A first. And so kind of put yourself at the corner here where the angle is. And so we're going to find whatever little a is and whatever side C is. So because I have this side that's opposite, which is 2, and I've got this side, which is, I'm trying to find the A, we can use opposite and adjacent, which is tangent. So we can say that tangent of 50 degrees is equal to the opposite side over the adjacent side. And then I would just cross multiply, and I'd have to divide on this problem to isolate the A. Just a note, though, that you can also, let me see, put this, let me erase that for just 1 second. You can take yourself and move yourself over to the other angle. And in doing that, sometimes it makes it a little bit easier to solve the problem, because what happens here is if I use 40 degrees instead of 50, when I use the opposite side over the adjacent side, which is a 2, see what happens. We're going to go tangent of 40 degrees is equal to the opposite side A over the adjacent side, which is 2. So for this problem, all I actually have to do is multiply by 2 on both sides. I'm going to cross multiply, which is A is equal to 2 times tangent of 40 degrees. And so for this problem, that's a lot easier than this one, which is I would have to multiply A times tangent of 50, and then I'm going to divide by, tangent of 50 to get, for 2. So this way is a lot easier. But I still need a calculator. So we're going to use the calculator, and in using the calculator, this one in particular is a TI Inspire. If you're using one from class or not, the TI 84 is also a great calculator. You do need to make sure that you're in degrees. So if you're not in degrees, you would just use this trackpad and kind of push yourself up to here and click on degrees, and then that would, if it's in radians or something else. So we're going to go to where it says trig and click on that, and I'm going to go over to where it says tangent. Tangent, you say the whole word. Even though you're just saying 3 letters, you say the entire word. So we have tangent of 40 degrees. I'm going to put a decimal because that's going to automatically approximate it for me. So I say tangent of 40 degrees, and I'm going to hit enter, and that gives me an approximation for tangent. I still do need to multiply by 2. So if I just hit times, my calculator will automatically pull whatever I have up here, the 0.839, and bring it down here to where it says answers, because now I want to times that by 2. And so my answer for little a is 1.678. So I'm going to go with 1.7, okay? And so little a is approximately 1.7. Okay, so we'll put that right here. Now, the rest is I do need to find side C, because it said solve the triangle. Again, that's finding all the sides and all the angles. So in order to find little side C, I could use Pythagorean theorem, or I could use sine or cosine. I'm just going to use Pythagorean theorem, and that says 1.7 squared plus 2 squared is equal to c squared. And so in order to isolate the c, or to solve for c, I need to square root both sides. And so c is going to equal the square root of whatever 1.7 squared is plus 2 squared, which we know is 4. And so we're going to do that first. So we're going to go over here, and we're going to say control second, which is going to give me a square root sign. I'm going to use parentheses because I want to say 1.7 quantity squared, or squared. There we go. And then I'm going to say plus 4. Close the parentheses and hit enter. And now I have approximately 2.6. So little c is approximately 2.6. And in this little world here, this makes sense because the hypotenuse has to be the longest leg, the longest side, because it's opposite the largest angle. So next one, we're over here, and we have to find all the sides and all the angles again. I am going to use Pythagorean theorem one more time. So I've got 2 squared plus 3 squared is equal to c squared. 2 squared is 4. 3 squared is 9. 4 plus 9 is 13. 13 is equal to c squared. I'm going to take the square root of both sides, and when I do that, I get c is equal to the square root of 13. And so that means this value right here is the square root of 13. And yes, you can make that into an approximate value. Not a problem. We do want to find both of the angles now, but realistically, I just need to find one angle because then I can subtract the other one from 90. So in finding angle B, let's say, put yourself here, and you actually now have all options. You can use tangent, you can use sine, you can use cosine. The reason being is you have all three sides. So I can use tangent again, because that's just nice because I don't have to use a root. I'm going to say tangent of angle B is equal to the opposite side over the adjacent side. And remember, you're trying to get angle B by itself. So that means this tangent is going to move across the equal sign. And by doing that, you're finding the inverse, which we call arctangent of 2 over 3. And so now we have angle B is approximately, not sure, let's look that up on our calculator. And in that, let's see, so we're going to go to trig, little button here, and we're going to go over to where it says arctangent, and we're going to say parenthesis 2 divided by 3. I'm going to close the parenthesis. Oh, I forgot the decimal, so instead of hitting enter, because I'll just hit it. See what happens? If you don't do an approximate value or you don't use a decimal, it actually gives you what you typed in. So let's do that again. So we're going to go trig. I want to hit arctangent. I'm going to go 2 divided by 3. I'm going to put a decimal there and then close the parentheses, and that's going to give me an approximation for my angle. So my angle is approximately 33.7 degrees, so 33.7 degrees. So that's the measure of angle B. And so if this angle is 33.7 degrees, right, what we can now do is I can go back to my calculator and I say, well, what's 90 minus 33.7 degrees? And that's 56.3. And so that is my angle A. So the measure of angle A is approximately 56.3 degrees. And I say approximately because we rounded. So it's not exact, it's rounding. The next problem is an application problem. It's not a solve the triangle, it's just find a side. So this is regarding a surveyor. Surveyor is very important because they are doing all of our very, very exact measurements. And so this person here is in the corner, and they have their transit, that's what they call this thing. And so they do sightings, and so this person is sighting on the other, they're trying to find this length, which is B, which is right here, okay? They sighted a point A, and when they did that, they had this angle of elevation, which was an angle of 20 degrees. They also measured this length to point C, and that was 200 meters. So all we have to do is find this length. I mean, like, what if you want to build a bridge or get a log that's that long or whatever? And so what you would be doing is we have to understand that this is the opposite side from where our surveyor is, and this is the adjacent side from where our surveyor is. This is the hypotenuse. We're not looking for that, so we don't need to find that. So I'm going to erase that. We don't care about that right now. And so in order to find this opposite side, which is B, we're going to say, again, what uses opposite and adjacent? That's tangent. So we're going to say tangent of our angle, which is 20 degrees, is equal to the opposite side over the adjacent side, which is 200. And then we're just going to cross multiply, and we're going to say B times 1 is B, and this is equal to 200 times tangent of 20 degrees. And so therefore, on my calculator, we'll go back there, and we're going to type in, we could just type it in all at once, actually. So I'm going to go 200 times, and now I have to go to tangent, and hit tangent, and then put in 20 degrees. I'm not going to use the decimal point this time because I want to show you that if you forget the decimal point, you can always go Control, Enter, and that above this, which is a little tricky to see, but there are these little approximates like that, and that's telling you the same thing that a decimal would do. And so anyway, our length, which is B, is equal to about 72.8, and I believe we're in meters. So this is 72.8 meters is the distance across that little water river. Two very important things that everybody gets mixed up about it at one point. But you know, when you're looking at the angle of elevation, you're looking up. Okay, it's very clear. It's always on a horizontal and it's looking up. When you're looking at the angle of depression, also on a horizontal, you're looking down, straight across. So it's like if you were flying in an airplane and your airplane decided to go on a descent, it's going to start going down. So here's my little airplane, and it looks like a hot dog, but that's okay. And so here's my triangle. A lot of people think that the angle of depression is this angle inside here, but it is not. The angle of depression is always based on a horizontal. So as soon as the airplane starts descending, it's going to drop down this way. And so this angle here is the angle of depression. Similarly, the angle of elevation also is on a horizontal, and that goes up. And so wouldn't you like to guess that these two angles are equal to each other? Because remember from geometry, which is one of your favorite classes, right? That these two lines are parallel, and therefore these two angles are what we call alternate interior angles. And so they're congruent, the same. And so therefore, anytime you see an angle of elevation connected to your angle of depression, those angles happen to be the same value. Just don't make the mistake of putting that inside there, okay? So here we are trying to find the inclination. So this is our inclination angle. This is our angle of elevation because it's going up on a horizontal. What we do know is that this elevation level is 8,000 feet. We also know that this elevation is 11,100 feet. But realistically, all I need are two values in order to find angle B. So what we're going to say is if I took 11,100 and subtracted 8,000, I'm going to get 3,100 feet. And that is my opposite side. So I have that bit of information. I also know that this trailhead right here is 14,000 feet in length. So therefore, what they're looking for is like a, what do they call that? A road grade, you know, like a rise over run, but I don't have the run. So you have some options. Number one, you can use Pythagorean theorem and find this side here and use tangent. Or, again, put yourself at the angle that you're trying to find or the angle that you're using. And you're going to say, let's see, opposite and hypotenuse. So the opposite side in the hypotenuse is sine. So we're going to say sine of angle B is equal to the opposite side, which is 3,100, divided by the hypotenuse, which is 14,100. So again, we're trying to find angle B. So we're going to say angle B is equal to, and we're going to take this sine and move it over to the other side. So that becomes arc sine of 3,100 over 1,400, or sorry, 1,400. That's not right either. 14,100. And so I'm going to use my calculator. I'm going to come over here. And I need arc sine. So I'm going to go trig, arc sine. And I'm going to say 3,100 divided by 1,400, 14,100. I don't know why I can't say that today. But press enter, and then we get about 12.7. So that means that the measure of angle B is approximately 12.7 degrees. And so that's my angle of elevation. Cool. Okay. This person is shooting free throws, and this person is 6 feet tall. The rim of the basketball or net is 10 feet tall. So the distance of this length right here that I need is actually 10 minus 6, which is just 4. We also know that this is the angle, and that's what they want us to find. What is the angle of elevation from the player's eyes to the center of the rim? So that's what I'm looking for. So we know this is 4, and that's my opposite side. We know that the adjacent side is 15. We don't know the hypotenuse, but we don't need that. So we're going to say from this person, from where they're looking, is opposite and adjacent. And this is, of course, a right angle. So we're going to say tangent of the angle that we're trying to find is equal to the opposite side over the adjacent side, which is 15. And so we would say theta is equal to arc tangent of 4 over 15. And we would use our calculator again. And so go over to your calculator, and you would say arc tangent of 4 divided by 15. I used a decimal there so that it could make it into an approximation. And my theta, my angle, is approximately 14.9 degrees. And so that's the angle of elevation, and from the player's eyes to the rim. That's what this angle is right here. For this problem, we have the CN Tower that's in Toronto, Canada, tallest structure in the Americas. While visiting Toronto, the tourists wondered what the height of the tower above the sky pod is. So if you don't know what a sky pod is this round thing like this. And so it's sort of like this round shape that goes around a pole. And you actually can like walk around it. And so you can, you take the elevator or you climb these steps, you go all the way to the top, almost the top, because that top is the point. And you walk around this. Sometimes they put dining there, and it's a little scary to be up that high for sure. But a lot of people like that because it's probably got windows all the way around. It's not my kind of thing. I'm afraid of heights, sort of. Okay, so what they're saying is they're standing, while standing 4,000 feet from the tower. So we're assuming that this person is standing like on the ground. So we'll say this is 4,000 feet across the water, of course. And let's see, what do we know? We know that she measured the angle to the top of the sky tower. So what they're looking for realistically is this length from here to here. They want that length. That's what they want. And so we're not moving. This person's still here. Somebody's standing there. And so we have actually two triangles. We have a triangle to the sky pod, and we have a triangle to the top of the tower. They want this length, okay, from here. Let's see, do I have it? They want this length from here to here. That's what we want. And so what we need to do is we need to use two triangles. So we're going to make a small triangle, same length, and that's smaller because she's looking not as far up. And so the angle there is going to be 20.1 because this person, right, whoever's 4,000, feet away, is 20.1. When they look up at the angle of elevation, it's 20.1. But think about if you're looking outside and you're looking up at the top of a tree, that angle is going to be different than looking up at the sky, which is a lot higher. And that's the difference. So when she looks up higher, the angle of elevation is more because your neck is like looking up farther. And so this is 24.4 degrees. And so also a right angle. But your distance is exactly the same. So what our job is to basically find this length here and this length from here to here, which is the top of the tower, from here all the way down, and then subtract them. So we have two different equations. So you're here, you've got tangent of 20.1 degrees is equal to opposite over adjacent. I'm not using the hypotenuse. So therefore, I'm not using sine or cosine because the hypotenuse uses, the sine and cosine use the hypotenuse. Now for this one over here, I'll put that in red. This one, that's going to be tangent of 24.4 is equal to the opposite side over the adjacent side, which is 4,000. And we just have two equations and we just have to multiply those across, right? So on the left, we have, let's see, x is equal to 4,000 times tangent of 20.1 degrees. And on the right, we have y is equal to 4,000 times tangent of 24.4 degrees. Okay, so let's figure out what these values are. Okay, so going over the calculator, I'm going to say, well, 4,000, whoops, that's not my calculator. Over here, I'm going to type in 4,000 and times tangent. So go tangent 2,000 20.1. Close the parentheses, enter. And so we've got 1463. So x is approximately 1463.8 feet. So the smaller to the sky tower is 1,400 feet up. But the other one, and we're over here again, is 4,000 times tangent of 24. Whoops, something happened here. Oh, I typed in tangent. That's a problem. Hello. So I got to go to trig and go tangent of 24.4. Whoops, 4. I feel like I messed up again. Hold on a second. One more time. Third time's the charm. 4,000 times. We're going to go trig, and we're going to go tangent of parenthesis 24.4, close the parenthesis, 18.14, so that's 1,000. So y for this one, so y is equal to about 1814.5, so 1,814 feet. So therefore, the distance up here, right, is going to be this. I'm going to subtract those. I'm going to go 1,814.5 subtract 1,463.8. So what is that? Let's see, 1,814.5. And we're going to subtract 1,463.8, and we get 350. That's pretty tall, actually. We have 350.7. We are in feet, so feet up in the air. That's how tall the tower is above the sky pod. And again, the sky pod is that round thing that you don't want to go up there because it could be dangerous. All right, finding the speed of a truck. I actually love this question. You have a state trooper, and the state trooper right here, hello, is hiding behind this rock, and that is a good place to hide. it's 30 feet from the highway. So this person is 30 feet away. This is going to be a perpendicular line. This length is just 1 second. Now, what does that have to do with anything? It has to do with the fact that it's just 1 second. After the truck passes, the angle between the highway. So this is the angle that I want. Actually, I have that. It says right here, 15. But 1 second after the truck passes, the angle between the highway and the line of observation is measured. So what I want to know is how fast is the truck traveling? Now, I just know that this is 1 second, but we want our answer in feet per second, check, and also miles per hour. So the first thing we're going to do is we are going to try, I'm going to erase this actually so I can see what's happening. And we are going to say, well, I'm here and this is 15. I need this length. Okay, that's what I need. So we're going to say tangent of 15 degrees is equal to the opposite side, which is 30, over the adjacent side, which I don't know what that is. I mean, I know it's 1 second, but that's not telling me. I'm in feet. Remember, this is feet and this is feet, but we don't know what this length is in feet. So we got to find that out. You can't measure one side in feet and one length in seconds. Okay, so they got to match. All right, so where we're at with this is we're going to have x times tangent of 15 degrees is equal to 30. Now I do want to solve for x, so I'm going to divide by tangent the whole quantity. So x is equal to 30 divided by the whole quantity, which is tangent of 15 degrees. All right, let's figure out what that makes, okay? So I'm going to go 30, oh boy, here we go. 30 divided by parentheses, tangent, right there. I'm going to go tangent of 15 degrees. I don't have any decimals here, so I am going to put in a decimal point. Close my parentheses and hit enter. It does look like the value of x, or the length, is 111.96. Okay. And that is, what is that? That is my feet per second. So that's feet per second. Okay, so that's how fast the truck is traveling. That is so cool that you can figure that out. Well, I mean, I don't have all the information yet because I really want to know how many miles per hour they're going. And so therefore, in order to find how many miles per hour they're going, we want to convert this from feet per second to miles per hour. So think about it like this. There's 111.96 feet per 1 second, okay? And if I'm trying to change this to miles per hour, how many miles? There's 1 mile is equal to 5,280 feet. But I do have to deal with the seconds because I'm going from feet per second to miles per hour. So I do need to change my seconds to hours. And so how many seconds are in an hour? That's the question of the day, right? Well, I'll tell you. In 1 hour, there are 3,600 seconds. I know. A little bit of trivia, I know that. We need to get rid of some of these things. We know we can cancel our feet out because feet are going to become miles. We can cancel our seconds out because our seconds are converting to hours. And so what we have left is this on top. So I'm going to use my calculator again. So, and of course I'm printing on here. I'm going to go over to my calculator, boom, and I'm going to go 111.96. I'm going to go, you multiply straight across. So times 1 is still the same value, but I do need to times that by 3,600 and get a value, which is not my answer because I still have to divide that answer by 5,280. Check. 76. And so therefore, this is so cool. 76.3 miles per hour. So 76.3 miles per hour that the truck is going. You can't win. They got you. And I mean, just knowing that, hey, if this is something that you want to do in your, police, and you want to become a police officer, that now you know how to do part of your job already. So anyway, I think I just really like that question. So you have homework. It's page 519. You have 5 questions. One of the questions is the speeding car, and you have to finish the other 2 parts to it. I will see you on Monday. I hope you have a wonderful rest of your day and weekend, and get your work done. Okay?